Hello everyone, welcome to the first of 4 Tree ID classes that I'll be doing throughout the month of June. If you don't know me already, my name is Bradley Simpson, the Restoration Fellow at Audubon Naturalist Society. My main role was being in charge of the comprehensive forest survey that was conducted within all the forest area of Woodend. Today we'll be focusing on oak and hickory trees, the trees that make up the most common forest type of both Maryland and Virginia, and most of the East Coast too. We will discuss winter and spring identification techniques, and then at the end, we'll use a dichotomous key called the tree finder to identify a leaf sample that I had collected a few weeks ago, and we'll practice using that. So with that, we will go ahead and begin. So again, if you have a question, the chat function is the best place to put those questions. My co-host Christian Maioli will be reading through these questions, and if one is very pertinent to what we're discussing, he will interject me with that question. I will also have natural breakpoints between topics where I'll stop and ask for questions as well. And if you have any at the end, I will make sure to leave plenty of time for questions then as well. Just make sure everyone is muted so that this will go as smoothly as possible. All right. So with all of our trees in the oak groups, we're focusing on our two main representations of both the two different types of oak groups, the white oak group and the red oak group. Within the white oak group, we'll look into specifics for our white oak, as well as discuss comparisons with chestnut oak, post oak, and swamp white oak. Same with the red oak group, we'll focus on northern red oak, comparing with all the other species that you see there. And then with our hickories, and as well as walnut, since they are in the same family, we will focus on bitternut hickory, and then compare with our other 3 hickory species common to this area, as well as our really common black walnuts. So in identifying trees, there are many different things that can be done when out in the field to find out what tree you might be looking at. So dichotomous keys are our main tool. It is a series of paired choices that uses characteristic features to differentiate different individuals and to get to a species identification for the tree you might be at. Apps have become very useful in doing this as well, where you don't have to have a book on you, just your smartphone. You take a picture, and with iNaturalist, you can upload it to this app, and an advanced learning system can help you identify it. It has done very well over the past few years of practicing identification, but it's always good to double check what it is suggesting to you. Virginia Tech Dendrology. So there's links throughout this presentation. I will be sharing this with people so that these links can be used and explored after this course. But the Virginia Tech Dendrology has really amazing resources on the species common in that state. The app it's somewhat of a combination of a dichotomous key and iNaturalist, where it will use your location as well as a selection of features that you choose that helps identify the individual you're looking at. The only difference between the two is that the Virginia Tech Dendrology does not use pictures to identify your tree. Both are very useful. Along with dichotomous keys, it is good to have other field guides that might give you some more information about the specific species that you are trying to identify. My favorites are the Common Native Trees of Virginia and the Bark Guide. The Bark Guide is for more northeastern trees, so those common in the south may not be in the book. But these collection of books listed here are very useful when trying to identify an individual. Now, sometimes the features, though characteristic, might not be very large and could be hard to see. Having a hand lens is a very, very useful plant identification tool. For most of your features, a 10x lens will be more than enough to see the features that are being referred to in the keys. Having a ruler, which most keys actually have already printed in one of the pages, it is good to have an extra one on hand to measure out certain features as well. And having a knife or pruner to collect your samples and maybe even take them home and give them a second look is also a good idea. Sometimes you even have to kind of look inside a stem and look at a feature called the pith, which is a soft, spongy part of a stem that carries nutrients, but cutting into that might be important, so having a knife or pruner. And then sometimes your tree might be a little too tall. You can't even reach a leaf. So having some binoculars on hand that can get you a closer look is also important. I was thankful to have, when I first started here, so thankful to have my boss, Allison, and our senior naturalist, Stephanie, buy a pair of binoculars for me when I was doing the first series of forest survey. And that helped me identify all of our trees at wood end. Now, in plant identification and botany as a whole, there are a lot of specific terminology used when identifying trees. Most of it is in reference to Latin and Greek roots. There's a lot of terminology here listed, and this is just an example to give an idea of the type of language used. Most of your keys will have a glossary at the end that will give you a good representation of the language being used, but the book pictured here, Plant Identification Terminology, provides an illustrated glossary of any botanical term you could think of, and it's very helpful once you start getting into more nitty-gritty plant identification. But some of the terms I want to highlight for us today, I will mention pretty frequently, are pubescent and glabrous at the top. So both are basically opposite of each other. Pubescent means with hairs, and glabrous means smooth, lacking hairs. And then also pendulous, which just means hanging or drooping downward, as well as a difference between terminus and axillary, which I will get more into at another slide, but I just want to mention that when we refer to a tip of a leaf, we usually call it the terminus, or if we're referring to an axil of the leaf in reference to bud specifically, we'll use the term axillary. But again, I'll get into this more in a future slide. But first, I hope that everyone collected their 3 twig samples to just get a better sense of what these features look like on a real individual. I'm obviously showing you these features through a computer screen, which is not ideal when trying to learn a plant. It's always best to be learning how to identify a plant right there in front of it, being able to take in the features with all the senses. So if you could get those out, we'll start discussing some plant features that are important for identification. So the first is deciding the arrangement of the leaves and buds along the stem. There are 3 main arrangement types, that is alternate, opposite, and whorled. So an alternately arranged individual will have leaves that are single, that don't have any other leaf opposite to it on the other side of the stem from it. So these leaves are solitary, as well as the bud. They are by themselves, whereas an opposite, they are paired leaves. So leaves on either side of the stem, or buds on either side of the stem, depending on your year. And then we get into a more complicated type of opposite, which is called whorled, where there can be 3 or more leaves or buds at one single point in a stem. So if you know our catalpas, which have the beautiful white flowers right now that you can see along 495, those trees, those catalpa trees, are whorled with 3 leaves at each point. So just see if you can look at your twigs and make a determination whether your individuals you collected are alternate, opposite, or world. Now, if your tree is opposite, you're in luck. It's probably going to be a little bit easier to identify. Opposite, there are fewer species that have obviously arranged leaves and buds. If it's alternate, there's a lot more options that it could be. And world, even better, even fewer. But just take a second and we'll move on to the next stuff, but still keeping our twigs in front of us and kind of using it to compare with what you see on the screen. So first, we're going to be discussing mostly winter identification techniques. I know it is not winter anymore. It is definitely almost summer with our 90-degree days that have been happening recently. But when I originally made these, I was helping UMD students learn plant identification, and I was asked to do winter and spring. So I thought, well, we might as well get into it here too. It's very important. Trees can still be identified in the winter, just using a little bit different features. So instead of looking at leaves, you're mostly looking at buds. So we have terminal and axillary buds. So a terminal bud is just a bud that's the end of the twig, and our axillary buds are ones that occur in the axil of a leaf. You can figure out where leaves used to be based off of the presence of a leaf scar. So there is a leaf scar at the pointed to at the bottom and at the top left of the twig. Those are just the remnants from when a leaf falls off in fall. Now, if your leaves are bigger, generally the leaf scar will also be bigger. And at each leaf scar, that is a node. So at any point where there's a leaf or a bud, that is the node of a stem. And between those leaf scars and buds is the internode. Those are the main features that you look for and that are referred to when doing winter tree identification. So at this time of year, the axillary buds might not be fully formed yet, but see if you can find them along your stem and see if you can find your terminal bud and just get a sense of making sure you know which one's terminal, which one's axillary. Sometimes buds don't have scales, but see if you can see any apparent scales on your buds. The scales are specialized leaf features that protect the bud and are sometimes hairy to give it some extra help. So those are twigs. That's the main feature other than bark that is used in winter identification. So again, like I said before, we were going to discuss terminal versus axillary, and it really just refers to the position of the buds along the stem. So terminal buds, also referred as apical buds because they're at the apex of a stem. They are at the end of a twig. Axillary buds occur at a leaf node. So it's in that gap between the leaf stem and the actual woody stem. And then there's the axil. So that bud would be an axillary bud. So make sure that you can see that on your twigs. All right. So this is a good stopping point just for our first round of questions. We discussed like the introduction to our winter identification characteristics. So I will take a couple of minutes to see if there have been any questions yet.
We had a question in the chat about the Sibley tree field guide book, and they're wondering if you had an opinion on that book.
So I'm not too familiar with the Sibley, but if it's anything like the Peterson guide, then which is one I'm more familiar with, those ones I'm pretty sure, or I know the Peterson one does not have a key, and it's really just a collection of pictures of the trees and descriptions as well. So it's really important if you're just beginning to do tree identification to get a book that has a key in it. The one I suggested at the beginning, the Tree Finder, is a really good introductory key to use. It is available at the A&S shop and for only $6 on Amazon. And it has over 100 different types of trees common to this region. And it even includes evergreen trees as well. Yeah, so, but having another book, so like the Tree Finder does not have any descriptions of the trees. It doesn't have its own page for any of the species within the book. So having a guide like Peterson to provide more descriptions about each of the species themselves is also a good idea to have. So I hope that helps and answers the question. I'm sorry for not being more familiar with the Sibley.
We had a question, should all twigs have terminal buds?
More than likely they do, but I'm pretty sure that there are some that do not have terminal buds, and that would be a distinct feature referred to in a key. It would ask you if there's a presence of terminal bud, so I would say that not all species have a terminal bud.
And then is there a difference between a node and an axillary bud?
No, so an axillary bud and a node. So the existence of an axillary bud would mean that at that point it is a node. So at any point there is a bud, it is also the node of a stem. And the space between the buds, so the budless parts of the stem, is the internode. Are there any more questions before I move on?
There are none in the chat, but if anyone has a question and wants to unmute themselves for a second, they can do so.
So it doesn't look like it, so I'm just gonna keep going. I'm gonna go species by species, looking at the three main ones I mentioned at the beginning, and talk about what is the distinctive winter features that you can look for on in those species. So for our red oak, the leaf scars and buds are arranged alternately along the stem. Now, the terminus of the oaks can actually be a little bit confusing because they don't have just one terminal bud. Oaks in general actually have a cluster of buds, usually 3 to 5 on average at the end of the twig. But it is a very, very distinctive feature of oaks too. If there is a clustering of buds at the end of a twig, it's most likely an oak. Our red oak buds are conical, they're cone shaped with very few hairs on it, if any. The twigs are very smooth with some pubescence, and they can even be a little bit glaucous, which is just a bluish greenish coating along the stem that can be easily rubbed off with a finger. The bark is dark, smooth, and shiny when young, becoming a little more ridged when mature. A lot of people refer to the distinctive ridges as kind of a ski slope pattern, where you can imagine skis going up and down the tree at different points. Now, for oaks in general, having dried leaves and fallen acorns can really help with identification, since some of the stem features can overlap between species. For our white oak, our leaf scars are arranged alternately here as well, and of course, at the terminus, we have our clustering of buds, but our bud shape is much more rounded than that of our red oak. The twigs are smooth here too, with only some pubescence, but the bark is distinctively different, forming into these light gray plates, and then it becomes very flaky with age, as you can see in the bottom left picture. And if you didn't know already, white oak is Maryland's state tree. That's pretty special to us. And then we have our bitternut hickory. So our bitternut hickory is also alternately arranged. Our leaf scars and buds are arranged alternately from each other. Now, if you notice here, underneath our buds, we have very large leaf scars, and that's because our bitternut hickory leaves, when they are out in the spring and summer, are also quite large. So thus it leaves a much larger leaf scar. The twigs are very stout, over 1/2 inch thick and tough, difficult to break with these light colored lenticels. And these lenticels, the little dots you see along the stem, are gas exchange pores that are important for the tree when it's undergoing its processes. The terminal bud is distinctively larger than the axillary buds. And as you can see, it's very long, slender, with this distinctive sulfur-like color. The bark is ridged similarly to a red oak, but the ridges are a lot smaller. And then within those ridges, there's a nice red inner bark that is visible and creates a nice contrast to the grayer outer bark. So that is the end of our winter part. I wanted to see if there are any questions before moving on and talking about spring identification features. All right, so there's no questions. I'll keep on going and we'll discuss what we see now, the leaves, maybe some flowers, and later in the growing season, fruits. So we'll start off with our leaves. And the first thing when discussing leaves is to decide whether or not it is simple or a compound leaf. A simple leaf is only one blade is attached to the twig by the petiole, and the petiole is the leaf stem that attaches the leaf to it to the stem of a tree. And we have compound leaves, which are a collection of multiple leaflets attached to the twig by a single petiole. The blade of a compound leaf is divided into several leaflets, where at the bottom of the leaf of the petiole there will be a bud. So the presence, the point at which the bud exists determines whether a leaf is compound or not. If you notice, there will be no buds between a leaflet and a compound leaf stem. The only place a bud will exist for a compound leaf is between the leaf stem and the woody stem in which it is born off of. And these leaflets are just a smaller leaf that is part of a compound leaf. So we think of our walnuts. Our walnuts are a collection of 11 or more leaflets. So it's a really big leaf. And usually our walnuts, as well as our hickory, have those larger compound leaves, and thus they have the larger leaf scars that I was referencing as well. So we'll move on from simple versus compound. You can have palmately compound or pinnately compound, and it just is referring to a palmately means in the shape of a palm. So the leaflets all stem from one single point in two separate directions, or a pinnately compound where it's one single stem and they're branched off, usually opposite from each other along that stem. So leaf shape and arrangement. For our leaf anatomy, there are many, many, many types of leaf shape and arrangements. It is not likely you'll have to be familiar with all of these, but being aware of the different shape leaves can take is important when you start with identification. There is lots of variability within and between species. But I will highlight a few. We have in our more top left, falcate, which we'll talk about later with our bitternut hickory. It just means it is hooked in the shape of a falcon's beak. Next to it, we have orbicular, which is just circular. We have ovate below that, which is egg-shaped, so fat at the point where the petiole is and skinnier at the tip of the leaf. We have obovate on our right side, which is just the opposite of egg-shaped. So it means fatter at the tip of the leaf and skinnier where the petiole is. We have elliptic, which is oval, and then we'll discuss lobed today in reference to our oak. And then I discussed compound leaves. Well, sometimes there can be leaflets can have leaflets. So in the bottom left, you see bipinnate. So it's a compound leaf with leaflets having other leaflets as well. So leaves can be decently complicated. If anyone knows of the plant heavenly bamboo or nandinas are actually tripinnate. They have leaflets that have leaflets that have leaflets. So it can get really interesting when looking at the leaves of plants. So we'll move on from our shape and arrangement and look into some more specific features of our leaves, starting with its bases and apex, so the tip of the leaf. Again, you will most likely not need to know all of these, but for our bases, it is important to highlight oblique, which just means that one base of the leaf extends further than the other. So this is very apparent in our elms. We have rounded, which is typical. We have cordate, which is heart-shaped, or cuneate, which is also pretty typical, which just means narrowly triangular at the base. For the apex, I want to highlight acuminant, which just means the leaf is basically pinched to a tip. That is very important in our tupelos or our black gums. We have acute and rounded. Those are what we see most of the time. So acute is just triangular, and rounded, just a rounded off apex. So we'll move on from our bases and apex and look at our venation and leaf margin, or the edge of a leaf. So for venation, there are two different types of veins. There's primary veins and secondary veins. Primary veins is the vein of the leaf that connects to the petiole. So it's basically an extension of the petiole into the leaf, forming the primary vein. And then secondary veins are branched directly from the primary vein. And that space between, just like we have axils on stems, we have vein axils in leaf venation. So these vein axils can usually have tufts of hair, which we will discuss later with our black oak when comparing it to our northern red oak. So I have it identified in our bottom left, which is primary, which is secondary. In our leaf margin, again, we have all different types of ways our leaves can look on the margin. We have ciliate, which is with fine hairs. This is usually only seen with a hand lens, so reiterating the importance of having a hand lens. So a dentate is symmetrical teeth, like our arrowwood viburnums. Entire is just even and smooth throughout. And then serrate, which is a little bit different than dentate because our teeth are pointing forward towards the tip of the leaf. All right. So then I want to discuss something that's very apparent in oaks, which is a comparison between sun versus shade leaves. So our sun leaves at the top of the canopy, those exposed most to the sun, are often going to be more lobed and more divided than those in the shade or the bottom canopy. And this is to increase the photosynthetic efficacy of each leaf on a tree. If our top canopy leaves were just as big as our bottom canopy, they would be taking up all the leaves in the bottom, taking up all the light for the leaves in the bottom canopy. So it would be almost pointless for the tree to have those bottom canopy leaves. But if the top were to allow more light in and then have it captured by the bottom ones, it really makes the tree much more efficient. So in northern red oak, this is very, very, very apparent. If at the end I will show, I collected my 3 twig samples too, but I have of course collected the species which we are looking at today. So I will bring out those samples towards the end once we get through our presentation. And I'll show you my example of sun versus shade leaves, but this picture gives a decent enough representation of what it looks like. So this is not just in red oaks, it's white oaks too. If you're familiar with mulberries, mulberries are more lobed at the top than they are at the bottom, as well as with sassafras. So lots of different trees take on this characteristic. So at this point, before just discussing the leaf features of our specific species, I want to make sure that there are no questions about leaf identification in general. So I'll pause here.
Bradley.
Hi, Adria.
Hi. So when you say that the leaf is more lobed, the sun leaves, you mean the lobes are wider?
So I will actually get into this when we start going to the dichotomous key, but I'll mention it now, that when there's a lobed leaf, the lobe is the extension of the leaf between sinuses. Sinuses are the depression. So I think you can see my mouse. This is a lobe. This part of the leaf is a lobe.
Right.
And then this gap between is called a sinus. So sun leaves will have deeper sinuses that are cut closer to the midvein. So the leaf is has a deeper sinus closer to the mid vein than do the shade leaves, which have these more shallow sinuses.
I get it. Thanks.
Mm-hmm. Any other questions?
So, Bradley, the three that are in that that gray area,
Yeah. Mm-hmm.
can you explain what those are? The one on the top, is that a sunleaf?
So the sunleaf, again, is the one that has the deeper sinuses. This middle one is kind of like middle canopy, so it's kind of has somewhat deeper sinuses than our shade leaf, which is the one all the way to the left. And you can see that it has almost little to no sinus because it is trying to capture as much light that reaches through the upper canopy as it can.
Okay, the one on the right looks bigger though.
Yeah, I don't know. Sometimes that can occur that they'll just be bigger in general. Usually I would say they would stay around the same size. But I had a TA in college who loved to say every day, leaf shape is variable. So even if there are different sizes, I wouldn't take it to heart. If you're finding it on the same individual, it just means that this leaf looks a little bit different because of the variability within the individual.
Okay, thank you.
Mm-hmm. Any other questions before we move on? About halfway through. All right. Well, I'm going to go ahead and move on. We'll discuss the specific leaf features that is distinguishable in red oaks, white oaks, and bitternut hickory. So for our red oak, like I mentioned when looking at the winter features, our leaves are alternate and they are simple. So again, you can see my mouse. There's just one leaf and there's a bud down here right at the twig. So because that's the location of the bud, from everything that extends beyond that is one leaf. So that's one leaf. Our leaves have variable lobing. Anywhere between 7 to 11 lobes are apparent. So remember, those are the extensions of the leaves between sinuses. So you can have 7 to 11 of these lobes. In red oaks, our leaves are bristle-tipped. And a bristle-tipped leaf refers to the extension of the vein beyond the leaf, forming a bristle, which is a hair-like structure on the margin of the leaf. So those bristle tips are these tiny little points right at the end of the leaf that is not apparent in white oak group species. So that is how you separate red oak and white oak group species in the spring and summer, is the presence of a bristle tip. If it is bristle tipped, then you have a red oak group species. If the lobes are rounded and not consisting of a bristle tip, then you have a white oak group species. They can be pretty large, anywhere between 10 and 24 centimeters. They're widely obovate, so remember that is the opposite of egg-shaped. So they're fatter at the end, at the tip of the leaf, and skinnier at the petiole, so the petiole, again, is this little extension of that primary vein that connects the leaf to the stem. Our leaves are glabrous, so smooth beneath, but sometimes having tufts of hairs, of stellate hairs in the vein axils. And stellate hairs just means that they are arranged in a radiating pattern like a star. And like I said, remember the vein axils is that space where the secondary vein branches from the primary vein. And this usually refers to the underside of leaves when it is talking about vein axils. So for a white oak, like in our red oak, they're alternate and simple. They have 7 to 9 deep rounded lobes with no bristle tip. They're glabrous or sometimes pale glaucous beneath. So glaucous is that blue sheen that can be easily rubbed off of a plant feature. And these ones can have even a larger range of size, being 5 to 25 centimeters. And they are kind of adorable when they're leafing out. So you see they're a little red when they're leafing out, and they're very striking when walking around to see that red feature just in the early spring when they're emerging. So for a bitternut hickory, our leaves are alternate and compound. So remember, compound, there is no bud between each of these leaflets. The bud would exist at the point in which this area of the petiole connected to the stem. So our Banana hickory can have anywhere between 7 and 11 leaflets, with its leaflets being serrate, so the teeth pointing upwards towards the tip of the leaf, and they're falcate in shape, kind of shaped like a beak of a falcon. All right. So then we're gonna move into flowers. But before we do, I just wanna make sure there are no remaining questions on leaves and leaf identification. Okay, if not, I will go ahead and continue and we'll talk about flowers now. Um, for the most part, keys will use leaves. Granted, they are out for a longer period of time than flowers, but once you start to get more in depth into or more closer to your identification, it might refer to flowers or fruits. So sometimes they might not be available to you, and that is unfortunate, but gladly right now we have lots of flowers. They can take a number of different types of arrangement, which is called an inflorescence. So for example, our oaks and hickories have an inflorescence called a catkin. And a catkin is a flowering spike. So a spike is where the flowers are unbranched from the main stem. So all of these have a main stem and the flowers are borne directly on that stem. They are separate male and female flowers, although they usually are on the same tree. That means that that tree is monoecious, where both male and female flowers are on the same tree. Sometimes you can have dioecious trees, such as hollies, where male and females are completely different individuals. So our catkins for oaks and hickories are wind pollinated and can also self-pollinate too, which means that flowers from the same tree can pollinate themselves. Ones that are more regular, like our rose and dogwood, they can usually be referred to in the number of petals they have. So for example, our rose is 5 meris, bearing 5 petals, and our dogwoods are 4 meris, bearing 4 petals. And these arrangements can get very complicated, such as our corums, which are common in viburnums, where each flowering stem is proportionally longer, forming a nice little flat head at the end. You have our spadix, which is the flower that is Jack in the Pulpit. Lots of different inflorescences, but we're mainly going to be talking about catkins, which is what I am going to discuss now with our oaks and hickories. So like me, I don't know if anyone else is like me, I'm parked under a nice big oak tree, and every morning the past few weeks I go out and I have a nice layering of green dust on my car. So catkins for oaks come out in kind of like the earlier spring, early mid-spring, and are just full of pollen. And like I said, they're wind pollinated, so that just a wind breeze coming by moves that pollen around and will connect with another flower. Hickories are the same. They also have the catkins, usually appearing a little bit later in spring, most generally having 3 hanging from each leaf axil. So that is our flowers. Before moving on to fruits, are there any questions?
We had a question going back to the leaves and how you were describing them.
Mm-hmm.
And they're wondering if you could reiterate what those terms meant. I believe that they were glabrous and glaucous.
Glabrous and glaucous. So glabrous means smooth. It means you can run your finger over it and feel basically nothing. No hairs, no roughness. It's just a nice smooth leaf. Glaucous means that it can still be smooth, but there is this bluish green coating along that feature of the leaf, so usually on the bottom of the leaf. And if you were to take your fingernail or your finger and rub that part, that sheen, it would come off. So that's what glaucous refers to, is just this bluish green coating that can be on the underside of some leaves. Are there any other questions? All right, with that, I'm going to move to fruits so that we can get to our dichotomous key with and end that with plenty of time to ask additional questions. So there are definitely tons and tons of different types of fruits. I list them all here, but I'm only gonna really mention the ones that are important for the species we're focusing on. So both our oak and our hickory is a nut. It is an acorn, and a hickory nut is a thick woody pericarp. The pericarp is the ripened ovary of a plant. So if you imagine the parts of a plant you usually eat, it is the pericarp. So they surround a single seed within our walnuts and hickory nuts and our acorns. But there are all these different types of fruits. So, and I provided some examples. And remember that I will be sharing this presentation so that you can give yourself an overview of what these look like. So when we go into more complicated fruits, you can have aggregates like our raspberries, where is the fusion of several different pistils of one flower. So that's the female flowering parts. They can aggregate together. We have berries and drupes. So serviceberry is a good example of a berry. But again, I just wanted to show these as examples, but mostly focus on what our oak and hickory looks like. So a big distinguishing feature for red oak group and white oak group also is in reference to the acorns. So the red oak group acorns, which are much higher in tannic acid, take 2 growing seasons to mature. And white oak groups, which are less bitter, are only mature in 3 months, 1 growing season. So if there is a presence of developing acorns as well as the presence of mature acorns on the same tree, you have a red oak group species. If there are only developing acorns, you most likely have a white oak group species. And looking at the acorns more closely, the white oak acorns grow up to around 3/4 of an inch and consist of these warty scales on the cap, which is very apparent in our picture. A red oak produces acorns that can get up to 1 inch long with a flat, thick cap that covers only about 1/4 of the nut. And our bitternut hickories nuts are obscurely angled and 4-winged. You can kind of see the presence of those wings in the picture here. And the husks split incompletely into 4 valves, so you can see that the wings don't extend all the way down the fruit. So that is our fruits for oaks and hickories. Before we run through a example with a dichotomous key, I want to make sure there are no questions.
We had a question, do bitternut hickories also take 2 years to develop?
No, the bitternut hickories, even though they are also bitter, I don't think it's tannic acid, but again, I'm not 100% sure on that. They are every year as well as the white oak.
Bradley, could I go back to the catkins? Are the male and the female, they're on the same tree, but are they generally in different parts? And if you look at the tree, can you quickly tell which is which?
So yes, they are in different parts. You won't see a male and female flower directly next to each other. It is difficult to identify which are the male and female ones. They look very similar. I know that there is one, usually the male or the female is higher up and the other one is lower in the tree. I am drawing a blank on which one's which, but I'm sure that in search would be able to answer that question.
Okay.
Yeah.
That's fine. Thank you very much.
Mm-hmm.
Can I ask about the catkins also?
Of course.
In just looking at the catkins, is there a way to tell the difference between the oaks and the hickories without looking at the rest of the tree?
I haven't really explored the difference, but just based off of observation, the hickory catkins look distinctively larger. But other than so if you're just looking at the catkins, the hickory they're pretty large. I mean, they're like almost a foot long when I was looking at them a couple of days ago, hanging from the tree. Are there any other questions before we move on?
At the bottom of the white oak, there is something on the left-hand side below the cap. What is that little small nut? What it looks like?
I actually do not know the answer to that question. It almost looks like, I don't know. I don't really know. It could be a bud, a flower bud for next year.
Okay, thank you.
But I do not know for sure. I'm just guessing at this point.
Sure, thank you.
Yeah. So I want to go ahead and move on so that we have time for a little bit more questions at the end. So I just want to give some comparisons with the species that I had mentioned at the beginning. So this is not encompassing all the oak and hickory species within this region, but these are the selection of the most common. Our black oak, which looks a lot like our northern red oak, except for its bark being much more platy, having these plates in it that you can kind of draw a perimeter around, as well as having this velvety orange pubescence in the vein axils on the underside of the leaf that is not apparent in northern red oaks. Our southern red oak, also more platy, having more plate bark than northern red oak, but not as distinctive in black oak. I call this one the middle finger oak because it has that really long lobe at the top tip of the leaf, which is very distinguishable from other oak species. Our scarlet oak, which I think is the tree that looks most like our red oak, it has similarly looking leaves with 7 to 11 lobes. They're often glaucous beneath, so that pale bluish coating. Their acorns, though, are larger, and the acorns of the northern red oak are larger, and the cap doesn't cover as much as the acorn when compared to the scarlet oak, which has a much smaller acorn, with the cap covering almost half of the acorn. And the scarlet oak generally has 5 to 9 lobes, whereas the northern red will have 7 to 11. In our pin oak, the leaves are very deeply lobed, having these sinuses that go almost all the way to the mid vein. We have willow oaks, which don't have lobes. I just want to show that not all oak leaves have lobes. And then our blackjack oak, which I like especially because of it having Maryland in the Latin name. We always see Virginia and Pennsylvania in the Latin name, but sometimes Maryland gets a shout out in plant Latin. So our blackjack oak, which has 3 large lobes at the apex of the leaf and not really anywhere else. And then with other white oak group species, we have our chestnut oak, which has very small rounded lobes around the leaf. Our post oak, which has kind of like a T-shaped pattern to it, almost looking like a fence post. And then our swamp white oak is like a combination of our chestnut and white oak, having a combination of the shallow and more deeply lobed rounded lobes. So I'll go in. This is from our Flora Virginia, and it shows just all the different shapes oak leaves can take. So I'm just gonna keep going through this and show the acorns. I want to highlight number 3 up here, which is our scarlet oak. So small acorn with the cap covering about half of the acorn, and our northern red oak, which is right here, which has a much larger acorn with the cap only covering the top quarter of it. So that's our big difference between our northern red oak and our scarlet oak. In comparison with other Juglandaceae species, so hickories and walnuts, of course we have our black walnut, which has a lot of leaflets, usually more than 11, and usually lacking the terminal leaflet right at the end. So this would be the terminal leaflet on the mocker nut, And the bark is usually either gray or very dark, having these very distinctive ridges. Our mocker nut, Caria tomentosa, the tomentosa refers to the botanical term tomentose, which means with dense hairs, which you can see along this petiole here. You don't even need a hand lens to see it. And when you touch it, you can feel how soft it is. We have our shagbark hickory, aptly named for its very shaggy bark when it's mature. and our pignut hickory, which generally has only 5 or 7 leaflets, and in comparison to our butternut hickory, which never has fewer than 7 leaflets. So I'm gonna skip the question break here, and we're gonna move right into our dichotomous key and just hold your questions until the end. So we're gonna run through the tree finder, the top right here, run through that key with a red oak sample that I took. This was before full leaf out, but if we wanna look at the features on a more mature leaf, I have those collected with me. So for most keys, when you get into deciduous broadleaf trees, the first question, of course, will ask you if the leaf or buds grow opposite or grow alternately. Like we discussed before, our oaks are alternate. So we would go to page 21, to our next one, which asks if our leaves are compound or simple. So we have a tiny, tiny bud here and no division leaf from the petiole, which means that we have a simple leaf, not composed of leaflets. So we go to page 28 and ask if we have teeth or lobes. We have lobes. Remember, this is what a lobe is and what a sinus is. Sinus is the depression between two lobes. And because our leaf has lobes, we'll go to 33. We're asked if our leaf is evergreen or not with the sharp spine. So this is seeing if it's a holly or not a holly. So our leaf is not evergreen, tipped with sharp spines. So we would go to the next page where this picture is shown. So this one uses we'll mention real quick, this key uses pictures to identify where you go to make your next choice. But most of the time it is using numbers. It'll have numbers that are going down that separate the decisions, whereas this one has pictures. So now it refers to our twigs and whether they have thorns along it. So as you can see from our twig, we have no thorns. So we're gonna go just below where we see that the picture for that choice. We're then again asked about our margin. Because we have lobed leaves, we'll go to page 51, which really separates out the oaks from everything else. If the margin has waves that are hardly indented, so waves, a term for that is undulate, so it's just a waviness of the margin. But since our leaf is lobed, we're going to go to page 53, and it asks how many lobes we have. We have many more than 4, so we'll go to 55. Or it asks for the bristle tip. So you can see these tiny little hair-like structures that extend beyond the margin of the leaf. Those are our bristles. And because our lobes are bristle tipped, we will go below to that picture, where it asks if our lobe is deeply lobed or not. And when it refers to deeply lobed, it means more than halfway to the midrib. So from this lobe, this sinus does not go more than halfway towards the midrib. So we would say that our leaf is not deeply lobed. A leaf that would be deeply lobed would be our pin oak, which has the sinus almost go all the way to the mid vein, that primary vein. So then it asks to compare with this one species, if it is small and white downy beneath. Our leaf is definitely not white downy beneath, almost hairless. And I showed a picture of a scrub oak leaf for an example, and you can really see what they mean by white downy beneath, where you can only see the hairs. Because our leaf is not thus, we would go below, where it differentiates between red and black oak. And like I said, our leaf is smooth beneath, not having those tufts of orange hairs in the vein axils, and more than 7 lobes. So with those features, we just ran through a key really quickly to identify a northern red oak. And with that is the end of our first tree ID presentation. So I'll open the floor once more for any additional questions.
So Bradley, can you easily tell yourself like the difference between a red oak and a black oak if you're just looking at the leaves?
just looking at the leaves and not looking at any other feature, and let's say that's the only sensation I'm using is my eyes. I'm not even touching it. It would be difficult.
Okay. Thank you for saying that, because I never can.
Yeah, no, the oak leaves, if you're just looking at the leaves and not taking in information from the other features, it can be very, very difficult, such as like the red oak and the scarlet oak. I mean, I can barely tell the difference until I start looking at other features.
Okay, thank you.
Yes.
Hey, Bradley.
Hey, how are you?
Hey, what is there a function for the pubescence on the lead?
A function? A function. Oh yeah. So protection usually. Sometimes it can take in more water, but
Okay.
if you're like a little bug walking on it, it's a lot harder to walk on a leaf with pubescence. So it is. It does protect it.
Okay.
And then it can hold on to water even if it's windy. The hairs will hold on to water more, so it helps with water uptake from the too.
Okay. Thank you.
Mm-hmm.
Bradley,
Yes.
I found this a really nice review, but I'm pretty familiar with dichotomous keys and all that. So for your following talks, will you be going through that process again, or just talking about these specific species?
So I am actually still discussing how my next ones are going to go, because we're still unsure how much of a continuation the courses are going to be, because we may have some new people. I
Right.
would like to run through the dichotomous key more often and also get into a little bit more complicated dichotomous keys towards the last one. So like ones that, so I have one, the Muncher's key to naturalized and landscape plants of the Mid-Atlantic. That one
cool.
is very nitty gritty, and I would like to have some show some experience with that. By the
Okay,
end.
I'm not aware of that that particular tome, and I would love to, because I'm both a native plant person and a gardener. So
I think I should be visible right now. So this is the book I'm referring to. I could put it in when we share the presentation. I can put in a link to this book, but this has like almost every single tree, even non-native, that you could find in the Mid-Atlantic region.
Oh, that is absolutely stunning.
Yeah. So if you don't want to go all the way full into the flora of Virginia, which is a lot more expensive, this is a good
I have that too, but well, particularly if you're in the burbs, you sometimes, unless you really know what it is already, you can't tell whether it's.
So this will have it. This will have just landscape trees like crepe myrtles and such that it will not be in Florida, Virginia.
Very good. Okay, thank you. That's worth the price of admission.
Of course. Thank you. Any other questions? I know that we're right around 8 o'clock right now. So I want to make sure there's no other lingering. Everyone should have my email, so if there's lingering questions, I do not mind. Feel free to ask those questions, or you can save them and come to the next one.